All right, here we go. So adding and subtracting rational expressions. So remember, whenever we add fractions, they have to have a common denominator before you can add or subtract them. So our first example here, they both have a denominator of x. So whenever they have the same denominator, it makes it super simple. You can just add the top. So we would say, okay, well, this would become 2 plus 4 plus x over x. All right, and so then we would just combine like terms. So 2 plus 4 gives us 6. So this would be 6 plus x over x. And remember, this is a term in itself, what I just circled. And so we can't cancel the x there. Okay, so that would be simplest form, but we would need to account for where x does not equal 0, because if x equals 0, we would have a 0 in the denominator and it would be undefined. Okay. So moving on to the next example, again, they have like terms because they both have an x squared in the bottom. So we would just have x minus, now this negative goes to both of these, okay? So it would be x minus 2x, and then x minus a negative is plus 3. And then it's all going to be over x squared. Okay, so combining like terms here, we do x minus 2x. That's going to give us our negative x. And then we'll have the plus 3 over, and then x squared. Okay, and again, we need to account for where x is going to give us a undefined, and that would be at x equals 0. So x cannot equal 0 here. Okay, let me turn my notifications off. Okay. All right. So now we move on to this one here. And so if you look at your denominators, then we don't have like denominators, but I know that 3 can go into 12. So I'm going to make my LCD, and I'm going to write it right over here in the corner. I'm going to make my LCD, least common denominator, be 12x. Okay. So in order to make 3x a 12x, I'm going to multiply it by 4. All right, and if I multiply the bottom by 4, I have to multiply the top by 4. And then same thing over here on this other side. I already have the 12, but I need to multiply by x. So I'm going to multiply the top and the bottom by x. So 4 times 10 gives me 40. And then 4 times 3x gives me 12x. Minus, and so then I'm going to distribute, if you will, this x to both terms here. 5 times x gives me 5x, and x times x gives me x squared over 12x. All right, so now I have common denominators, so now I'm just going to take the top, and I'm going to subtract it. So I'm going to take minus 5x, and then again distribute this negative to my x squared, so negative x squared, and it's all over 12x. Okay, now I will tell you, normally we would write it in standard form. She does not. She actually leaves it written like this, and so we would just write it like this. Okay, and so we need to account where we're going to have a undefined value. Ignore the 12 because really we can separate this to be 12 times x, and 12 isn't an x value, you know, it's just a 12. But where x is 0, it would be undefined, so x cannot equal 0. All right, moving along. So now we have terms or fractions where we have x and x squared. So I can multiply x by x to give me x squared. So my LCD here is going to be x squared. So I'm going to multiply the top and the bottom by x. So 3 times x gives me 3x, and x times x gives me x squared. Now I already have an x squared on my second fraction, so I don't have to multiply that by anything. So 14 over x squared. So now that we have common denominators, we can just add the top. So 3x plus 14 over x squared. And then again, we have to account for our undefined value, and that would be where x equals 0. So x cannot equal 0. All right. So now this one can get a little tricky because now we move into like x plus a number. And so when you have x plus a number like this, or x minus a number, if you will, in a minute, we're just going to make our LCD be x plus 3. Oh, crap, let me move that over. So LCD is going to be x plus 3, x plus 4. Like it's going to be both of those kind of being multiplied. We're not going to actually FOIL it out, but that would be what we would multiply. So I have on this fraction that I'm going to circle in red, I already have the x plus 3. So the only thing I need is the x plus 4. So I'm going to multiply both the top and the bottom by x plus 4. All right, well then in the fraction I'm going to circle in orange. Sorry, I already have an x plus 4 on my denominator, so I need to multiply by the x plus 3 on both the top and the bottom. Okay, so go ahead and distribute that. So x times 12 gives you 12x, and 4 times 12 gives you 48. Now, when you write out your denominator, you're just going to put in parentheses x plus 4, x plus 3. You would just write it like that. Okay, and then plus, and then I'm going to distribute again. 6 times x gives you 6x, and 6 times 3 gives you 18. And the same way here, this would just be x plus 4 times x plus 3. All right. So now that you have a common denominator, we're just going to add like terms. So we're going to add our x's together. So 12 plus 6 gives you 18, and then x. And then 48 plus 18 gives you 66 over, and then we're just going to keep our denominator the same, x plus 4, x plus 3. She does take it one more step, though, because 18 and 66 can both be divided by 6. So she's going to simplify the top. So 18 divided by 6 is, or 18x divided by 6 is 3x, and then 66 divided by 6 is 11. And it's over x plus 4, x plus 3. Okay, and then x cannot equal negative 4 and negative 3. Okay. All right, so now we move over here. And so these are actually pretty close, and someone might not pay attention and think, oh, they have the same common denominator, but they actually don't. Okay, one's x plus 8, one's x minus 8. So since they have different denominators, we are just going to say, okay, well, our LCD is going to be x plus 8 times x minus 8. Okay. And so, kind of out of room from over there, but all right, in green. Okay, so my fraction on the left is missing the 8 minus 8, or x minus 8, excuse me. So I'm going to multiply by x minus 8 on both sides. And then my fraction on the right is missing the x plus 8, so I'm going to put x plus 8 over x plus 8. Okay. All right, so just distributing our 8. 8 times x gives me 8x. 8 times negative 8 gives me negative 64, and it's all over x minus 8, x plus 8. All right, and so then we would do minus, whoa, sorry, I don't know what that was, minus, and then I'm going to distribute, so 8x, and then 8 times 8 gives me 64 over x plus, or 8, x minus 8. X plus 8. It doesn't matter which order you keep it in. Sometimes if you put like a plus here and a minus there, right there, sometimes you might think, oh my goodness, they're not the same just because they're in a different order, but you don't have to do that. Okay, you can just, it doesn't matter. Remember, multiplication, it doesn't matter which order it's in because it's still being multiplied together. All right, so we're going to do 8x minus 8x. Okay, so that's just going to cancel. And then negative 64 minus 64, and so that is going to give us negative 128. And it's all over x minus 8, x plus 8. All right, and so that's going to be where x does not equal 8 and negative 8. All right. Excuse me. All right, so on the last one, or next to last one, sorry. So one thing that we can do, like, so I have a 3, and I see that 6 and 9 can both be divisible by 3. So I'm going to factor this to 3 times 2x plus 3. And the reason I'm going to factor that is because now all I need to do to have this fraction have a common denominator is multiply by 2x plus 3. So our least common denominator is going to be 3 times 2x plus 3. Okay. So bringing the first fraction down, I have 2x over, remember I have factored that to be 3 times 2x plus 3. So I already have the common denominator that I need for the first fraction. And so then minus, I'm going to go ahead and multiply this by 2x plus 3 on the top and the bottom. All right, so x times 2x gives me the 2x squared, and x times 3 gives me 3x over, and then we would just leave it as 3 times 2x plus 3. Okay. All right, and so remember, well, you don't always have to do it this way, but just because I'm a creature of habit, I'm going to put my highest exponent first. So there's nothing on the right side, or left side, excuse me, that has an x squared, so it would just be like 0 minus 2x squared, so that's going to be negative 2x squared. And then 2x minus 3x gives you a negative x. And it's all over 3 times 2x minus 3. Okay? Now I can simplify the numerator because they both have an x in common. So that's going to be x times, hold on a minute. Let me pause for a second. Oh yeah, she has an error here. Okay, so x times negative x. I'm going to pull out a negative x right here, actually. Sorry, because they're both negative. So we have a negative x times 2x plus 1 over 3 times 2x minus 3. Just look at my copy. Okay, and so the only hole is going to be right here where I underline the teal. That's the only hole that we're going to have. And so I'm going to go ahead and solve it out just in case anybody needs that help. To see where x cannot equal, we're going to take the factor 2x minus 3 and set it equal to 0. And then solve for x. So I would add 3 to both sides. Oh. So 2x equals 3 divided by 2. And we have x equals 3/2. Oh, but I had a typo, or I miswrote. That's supposed to be a plus. Okay, hold on. If you don't need me to go back and redo this, then you can just skip this part that I'm about to do. Okay, so this should have been a plus 3. So I would subtract 3 from both sides and get 2x equals negative 3, and then divide by 2 and give me x equals negative 3/2. So x cannot equal negative 3/2. Okay. All right, and the last one, and this one, there kind of is a little bit of writing. I will be honest with you, just a heads up. All right, so on the last one, so because the denominators are both trinomials, we need to go ahead and factor them. All right, so I'm going to do the denominator the first in red. So x squared minus 2x minus 8. We're going to do x minus 4, x plus 2. And then the factors of this other one, I'm going to use, let's just use pink. All right, so x squared plus 2x minus 24, that's going to be x plus 6, x minus 4, okay? So now we can see, I'll just use the blue. So a minus 4 and a minus 4, so they both have minus 4s. So I'm going to make my LCD be x plus 2. Because that's one of the factors I have. X minus 4, because they both have it. and then x plus 6 because that's one of the factors of the denominator on the second equation. All right, so what that means is, okay, I'm going to rewrite this for y'all with the factors. So I have x plus 3 as my first fraction over x minus 4, x plus 2, plus 2x over x plus 6 times x minus 4, okay? So looking at what our LCD is, we see that like my first fraction is missing an x plus 6. So I need to multiply the top and the bottom by x plus 6. And my second fraction is missing the x plus 2, so I'm going to multiply the top and the bottom by x plus 2. Okay? So then when I distribute over here, I get x, or when I FOIL or however, I'll do it over here so that way, in case anybody needs it. So we have x plus 6 times x plus 3. So we get x squared, 6x, 3x, and 18. So my numerator of my first fraction is going to be x squared plus 9x plus 18 over, and it's going to be all three factors together, x plus 6, x minus 4, x plus 2, plus, and so this one we don't have to do the box method because it's simple multiplication. 2x times x gives me 2x squared, and 2x times 2 gives me 4x. And again, it's all over x plus 6, x minus 4, and x plus 2. All right. And so from here, we just combine like terms. So x squared plus 2x gives me 3x squared. 9x plus 4x gives me 13x, and then I have the plus 18. And it's all over x plus 6, x minus 4, x plus 2, where, we're almost finished, x does not equal negative 6, 4, or negative 2, okay? All right, so if you have any questions on these, feel free to email me. I'll get back to you as soon as I can. But that is going to be the adding and subtracting rational expressions. So the important part is to remember you have to have like terms in order to be able to do that. So like I said, if you have any questions, just email me and I'll get back with you. Thanks.